You can test for fertility. So we've tested for drainage, we can test for structure and texture, we can test for fertility. And what you get when we're talking about fertility is you get nutrients, the major nutrients, and you don't need to know this, but it's important on fertilizers, NPK, nitrogen, phosphorus, potassium. Those are the three numbers that fertilizers have to show by law. But there's also major nutrients. Plants use a lot of calcium, they use a lot of magnesium, they use a lot of sulfur. They also use a lot of carbon, hydrogen, and oxygen, which come from air and water. But there's a lot of minor nutrients too, which are also called micronutrients: iron, manganese, molybdenum, boron, zinc, copper, chlorine. Those are what you find in some fertilizers for special plants. And you can test for those. Soil tests through the extension or many of the soil testing labs will automatically show you the major nutrients: magnesium, calcium, phosphorus, potassium. You generally have to pay a little extra to get nitrogen tested. And in our soil here, Steve and I have soil that is way below optimum with potassium, pretty common in Michigan, and way above optimum has become common in Michigan, maybe because we're using the land differently, maybe because we're putting in more fertilizers. And that's not necessarily a good thing. You want to watch those kinds of things. I would like to see on my next soil test, and we're due for one now, it's been 3 years. I'd like to see that the potassium has come up and maybe the phosphorus is dropping down because we're not adding any of that. The amount of organic matter also affects your fertility because organic matter is potential nutrient. For every 1% humus in your soil, that can represent a pound of nitrogen in that soil, a pound of nitrogen for every 1,000 square feet. It's also a watered reservoir when you have organic material, and that moisture layer becomes a platform for biological activity, and the microbes and grubs and insects and other organisms like nematodes are breaking down the organic matter, and their excrement is fertility. So our soil, when we started out, had less than 1% organic matter, and we'd like to have 5% or more. So that's another thing we'll be watching for, and why we will do a soil test after a few years. We'll retest to see how we are doing, and hopefully coming up in that organic matter. You can also test for relative acidity. This is pH. People are always into the pH of the soil, which is not nearly so important as anybody makes it out. There's also a cation exchange rate. That's how well soil can hold nutrients. And those are two things that you watch for. So our soil pH here, at least when we started out several years ago, is 7.5. That's alkaline. It's not worrisome to me, but it's alkaline. If I'm growing plants that love acid soil or require acid soil, I might have to do some working on that. I don't worry about it though too much. This is from the U.S. Forestry Service new soil quality index rating, and explains what rating they give for different pHs. Strongly alkaline, preferred by plants adapted to that pH range, possible boron and other toxicities for other plants. But if you look at 7.5, that's slightly alkaline, optimum for many plant species, except those that prefer acid soils. I'm not worried about this. If I was growing something like blueberries or rhododendrons, I might have to think about that. Cation exchange is much more important and much less understood by gardeners who are doing this thing. I would love to see a cation exchange. How much nutrient can the soil particles hold and then release to plants over time? I would much rather see 15. 15 would mean, wow, this soil can hold some nutrient. I can put some fertilizer on at the beginning of the year and it'll gradually be released to the plants because the soil is holding it. My soil, which is sandy, doesn't hold nutrients very well. Clay holds it much better. I don't want to see 20 cation exchange because that means that it holds it so tightly that roots can't get a hold of it. So I'm looking for those things, and that's the kind of stuff I get when I test my soil. This is it's an older one, so that might look a little different now. But if I get a soil test through Michigan State's Soil Nutrient Testing Service, I'm going to get a box, instructions, and a form. and I'm going to fill out the form after I have sampled my soil. And the directions tell you how to sample your soil. You're going to go to several different places. 7 to 10 is what I usually work with, where I scrape away the organic stuff at the top and take soil from about 4 inches down and mix the samples together, taking out rocks and sticks and stuff. I'm going to mix them together. And then I'm going to put a small amount into a plastic bag for Michigan State, other things for other places, and send that in to the lab, telling them what I want to grow. I use their instructions and I explain that I want to grow turf, or I want to grow trees, or I want to grow ornamentals, or I want to grow vegetables. And I can even specify which vegetables I'm growing. So at this point, I need to find out if there's any questions before we go on, because now we talk about what we do with those results of those tests that you can do.
Yeah, so we've got possibly maybe some of these would work better in the next section in terms of what we do, but some testing questions. Oh, sorry, back actually a little bit earlier. Barbara says, will jumping worms affect soil composition, or do they just affect that top organic layer?
Jumping worms affect the soil microbial life. Jumping worms eat organic matter, can consume organic matter so quickly that they deny other organisms in the soil a chance to thrive. And that's the problem with jumping worms, is that they're bullies. They're ogres. They're mass consumers. So it doesn't affect this. It can affect everything in the soil because it affects the microbial life of the soil, but they don't directly affect the structure and the texture. They're working on the surface.
Okay, great. So Mary is saying she has not had any success in finding fertilizer that is phosphorus-free, and looking for recommendations, perhaps from folk in the chat as well, if you guys have phosphorus-free fertilizer recommendations. Phosphorus-free fertilizer favorites. There we go.
There you go. Phosphorus-free fertilizers will have a 0 as the middle number. And there are phosphorus-free fertilizers in many places now, required by state law, that less phosphorus get put on the soil. For instance, Ohio and West Virginia, Maryland and Delaware, I think, all require that if a professional company fertilizes a soil, that they have on file a soil test that says it requires phosphorus, or else they can't put phosphorus on. So they're out there. I have not been out looking for fertilizers this year, and I'll explain that later. But they're out there.
Okay. Teresa is wondering, what's a good calcium number?
What's a good calcium number? Okay, one of the things that we're going to look at is different soil tests that you can do yourself or do through other companies. And one of the disadvantages of going through another company rather than through your extension is that how much calcium is good in a soil is relative to what kind of soil it is, as well as what plants you're growing. We're high in calcium in my area, and we can be too high in some cases, and calcium can lock up with other nutrients and make them unavailable. But I rely on our Michigan State Extension to help me understand when it's too much, and they'll tell me it's over optimal, but there's not a set number for that.
Okay, so Teresa's saying, for instance, from MSU, she got 2878, but it sounds like if it wasn't flagged in that result as being a problematic number, then it's probably within range for their tolerances.
Correct. If you went through the extension and they said they did not tell you it's a problem, it's not a problem.
Yeah, great. Nancy is curious if there's a shelf life for dry fertilizer.
Fertilizer, if it's dry fertilizer, granulated standard fertilizer, the shelf life is only impacted by whether or not it's still granular. In fertilizer companies where they make this in huge amounts, they dynamite the piles once in a while if they start getting solid. And so if it gets solid, you might not be able to use it anymore. But as long as you can still break it up, it's still usable.
Great. Then we have questions from Stacy, David, and Lin about preparing the actual bed area, adding organic matter, when to add. I'm assuming that will come with the next section.
Right. We're moving into that section.
Yep. Okay. So Stacy, David, Lin, we gotcha.